In this repair video, we're going to be working on an iPad 5 that came in for no power. Customer came in locally, and he said that he was using the tablet yesterday, no issues at all, but this morning he tried to power it on and nothing came on the screen. The tablet was never open before, no drops, no liquid spill, nothing like that, but the tablet suddenly decided to stop working. So the first thing I did was use a TriStar tester. I plugged it into the lightning connector here to check and see if our charging circuit is good, our TriStar chip is good, our charging flex cable is good, and all passed. So we know that we do not have a problem with the charging circuit. I asked Big Boss to replace the LCD. I thought maybe what if the LCD is bad? He replaced the LCD and same thing. Nothing is showing up on the screen. And then I asked him to change the battery. What if the battery is shorting out and causing the tablet not to power on? So we did replace the battery and still the tablet is not powering on. The strange thing is the tablet is charging at the right rate. So if we plug the charging cable, the correct charging rate is about 1 amp. And the tablet is charging at about 1 amp. Look at this. I do not know if you can see it, but the tablet is charging 5 volts at 1 amp. And that's the perfect charging rate. So we know that the battery is being charged. But if we try to power it on, nothing. Look at this. Screen is black. Nothing. Usually if you press on the power button, amps will go down to 0 and then it will start to go back up. But right now it's stuck at 1 amp. I mentioned this before. If the reading of amperage being drawn is 0.4, 0.5, 0.6, 0.7, even 0.8, we know we have a short. But I never seen a tablet that is charging at 1 amp that does not power on. And like I said, this tablet has never been opened before. So a 1 amp charge rate is perfect. Unless we have a 1 amp short on the board. That's the only thing I can think of. We do not have any fluctuating reading. Like let's say 1 amp, 0 amps, 1 amp, 0 amp. We do not have that because that's almost always a problem with the CPU or RAM. But right now it's a steady 1 amp charge and the tablet is not powering on. The fact that this tablet has never been opened before, that tells me that our backlight circuit should be good, our FPC connectors should be good, our backlight diode should be good. So what else could be causing the tablet not to power on? Let me disconnect the battery or just put a separator between the battery and the motherboard so we can disconnect the screen, because if you disconnect the screen without disconnecting the battery first, you're going to end up blowing the display or backlight circuit. Let's put the screen on the side. And that's our battery, our brand new battery. And let's take a look. We already removed this plate that goes on top here. We popped it open. And I also removed that tape that goes on top of the FEC connectors. We want to inspect everything and we want to look for anything obvious, maybe a burn mark or a blown component or whatever the case may be. I just want to see if everything looks visually good. Hence the visual inspection. And honestly, I do not see anything wrong in this area. Meter in continuity mode. I just want to do some quick measurements. What if we measure this filter from here to here? It's good. And it's good. We have 2 caps here. We have 2 resistors here. Nothing look obvious at all. Super clean. I mean, this tablet was never opened before, so it has to look clean from the inside. And what if we try to measure the backlight diodes? We should get a reading of about 0.14 voltage drop. .14, perfect. And this one should be 0.14 as well. And that's what I got. So what is the problem? What is the problem? Let's measure this diode here. And look at that. We have a short here. We have a short. Let's flip the probes. And we have a short. I think I already found what the problem is. Let's see if you can tell. If your eye is trained to look for issues, you should be able to see it. Where is it? I do see a problem. It may or may not be a problem, but I do see something. All right, time is up. This component does not look good. It looks discolored, and I see possibly slight burn mark on it. Now, that may be good, but based on what I can tell, based on the colors of surrounding capacitors, this one looks off. If you look at this one here, it looks healthy. We do not see any burn marks, even though the color of the cap looks different, but it looks healthy. This one does not look healthy. So that may be what's causing the problem. We do not know. What I'm going to do for now is inject voltage. Not here, not here. You know what? Before we inject any voltage, let me just confirm that we have a short. I'm just jumping 2 steps at a time. We should do it step by step. Let's measure here. And we do have a short. You see? And we do have a short. So right now it's going to be hard to point the voltage injection probe here because it may touch this or this. So what I'm going to do is point the probe right here. We have a lot of room here to point the voltage probe here. And we're going to inject 1 volt and monitor the board under a thermal cam. Then we can see what gets hot. And we'll be able to pinpoint where the short is coming from. Consider the job done, right? I'm going to connect my ground probe here, like this. And we're going to inject 1 volt onto that diode. Right, and let's see how it goes. So what happens when we inject voltage right over here? Right now, nothing is happening because probably my ground is not connected properly. Let's try it now. Look at our voltage injection tool. It's showing 4.8 amps being drawn by this board. 4.8. So something must get hot under the thermal cam. Let's switch over to the thermal cam and see if we can pinpoint where the short is coming from. Let's inject voltage on that diode and see what happens. One, 2, and 3. And look at this. I'm injecting voltage right here at the diode and something got hot right next to the diode. Right to the left, right to the left. To the left of the diode. Look at this. I inject and something to the left of the diode is getting hot. You see it? And what's to the left of the diode? It's that cap. So look here. That's our diode. When I injected voltage here, something on the left got hot. Something not too far away from the diode. And it's very likely, and I would say 99.9% chance that this capacitor is what's causing the short, based on the shape of that capacitor. I mean, I was able to tell before we even injected voltage. Let's go ahead and remove this capacitor. And we're going to do it the old-fashioned way, where we're going to rip that cap off. There's no other way. We do not want to apply a lot of heat, so we do not disturb all the caps in this area. The area is very crowded. Just like that. We're going to have to wait until the board cools down a bit because I mentioned in the previous video, if you test caps while the board is still very hot, then you may end up with a short, and you may think that you still have a short. So we're gonna have to wait a bit until the board cools down, and we'll test again. All those capacitors are connected in parallel. If one of them is out, it doesn't matter. It's not gonna affect the functionality of the tablet in any way, shape, or form. And I did an example in a previous video where I said, let's say you have 100 police officers guarding a building, and one police officer called in sick. Is that going to disturb the security of the building? Of course not, because you have 99 more officers that are guarding the building. One of them is sick, it's not going to affect the security of the building. So one cap out is not going to affect the functionality of the tablet, because these are bypass capacitors, and there are a lot of them. That's why you see a lot of them here. Instead of the factory installing one big cap that may not fit or that may be too high to install screen over, what they do is they put a lot of tiny caps and they spread them over. So one cap out will not affect the functionality of the tablet. Let's go ahead and measure and see if we still have a short. Meter in diode mode. And we want to test the second pin right here. And the short is gone. The short is gone. Let's test the diode. And we do not have a short at the diode anymore. That's it. Problem is fixed. And some of you will ask, are you going to replace that capacitor? And I've mentioned this in many of my videos. No, we are not going to replace that capacitor. Right now, we can replace that capacitor, but we're going to run into a risk of possibly knocking components off, because this is a very crowded area. So maybe if we applied hot air to solder that capacitor in place, we may end up disturbing solder balls under this chip, or we may end up knocking components off the board because it's a crowded area. So we do not want to take that risk. That one tiny capacitor is not going to affect the functionality of the tablet, and the risk to install one is higher than usual. So we do not put that cap back. Right now, all we have to do is put the screen back. And see if the tablet will work. We cannot just talk the talk, we have to walk the walk. Okay, let's connect the cable. And look at that. Look at that. Tablet is working. That's it, the job is done. Look at that. The job is done. Disconnect the cable, and the battery does have charge. Let me know what you think. We're gonna end the video right here. I hope you enjoyed it. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.